Good morning, everyone. Welcome once again to our e-maths class. We started with binomial theorem and we're looking at Pascal's triangle. So we're going to continue and look at other expansions using the Pascal's triangle.
Sir,
Yes.
sir,
Yeah, I can hear you.
please, I think after 3a square x square, the 3ax is not supposed to be 3ax. It's supposed to be ax, is it cube or whatever?
AX cube.
Yeah, in the middle.
Yeah, I agree. You say you omitted that step.
Which are you talking about? You mean?
So say in your
Yeah.
second step,
Yeah.
the second step, so you omitted the multiplication of a by x cubed.
Yeah, sir, that one. That's it.
That is what it's trying to say.
Where we have the 3ax cube.
So say after 3ax cubed, a should multiply x cubed. After 3ax cubed,
Yeah.
a should multiply the last term of the second bracket.
Yeah.
That's what it's trying to say.
Okay. It's recording now. Okay, then quickly fix that. It's an oversight.
So fix what?
The a plus as cube, yeah. After 3as cube, we must have plus as cube. When we simplify the second expression, that's the a plus s into bracket times the simplification of a plus s cube. The third step, that's the second to last, before the final answer, we have a exponent 4 plus 3a cube x plus 3a squared x squared plus a cube x plus 3a squared x squared plus 3a s cube. Then we must have plus as cube plus x exponent 4.
Please, I don't get you. Can you come over?
Okay, I'm taking it again. A exponent 4 plus 3a cube x plus 3a squared x squared plus a cube x plus 3a squared x squared plus 3a x cube, then plus as cube plus x exponent 4. Please, are you okay now?
Yes, please.
Yes, sir.
Okay. So when you add all of those by grouping like terms, we must get a exponent 4 plus 4a cubed x plus 6a squared x squared plus 4a s cubed plus x exponent 4. Any question? Okay. Now let's go to the Pascal's triangle. Let's consider the following expressions. For the example A, you know that anything exponent 0 is 1, right? So a plus x into bracket or exponent 0, that will give us 1. So for that particular expansion, we have 1 over there. Then example B, we have a plus x exponent 1. And anything exponent 1 is the same thing. So that gives us a plus x. C, a plus x all squared. And that gives us a squared plus 2ax plus x squared. Then the D, the E, and the F, when we expand them, we get their respective results. Now, to the extreme right end, what we have in the brackets are the coefficients of each term in each expansion. When you look at the first expansion, 1 is just 1. Coefficient of 1 is 1. When we look at the second expansion, coefficient of the first term a is 1, and coefficient of the second term x is also 1. So we are listing the coefficients in the order of the terms in the expansions in their respective order. The third example, you could see the coefficient of a squared, that is the first term, is 1. Coefficient of ax is 2. Coefficient of s squared is 1. Please take note, when we say coefficient, coefficient is a number multiplying variables. That is what's written by coefficient. So when you have two variables and you're holding one variable constant, that means you are telling us that that variable which is constant is a number. So that variable becomes a coefficient of the variable. But in this case, we have some 2 variables, some 1 variable. So the number multiplying the variables are the coefficients. The D, we have the first coefficient to be 1, the second one to be 3, the third one to be 3, and the fourth one to be 1. And then the last, the E, we have the first coefficient to be 1, the second coefficient to be 4, the third coefficient to be 6, the fourth coefficient to be 4, and the fifth coefficient to be 1. So we have 1, 4, 6, 4, 1. Then the final example, we have 1, 5, 10, 10, 5, 1. Okay, let's continue. But if you're not okay with something, you can raise up your hand and ask your question before we continue. Answer, please mute yourself. Unless you have a question to ask, then you unmute the audio. Thank you.
Sir,
Yes.
please, I have a question.
Ask.
Sir, in the previous slide,
Yes.
sir, please go back to the previous slide. There is still a mistake there. A cube x. It must be x cube plus a cube x.
Are you talking about the final answer?
No, yeah, before the final answer in the middle.
Uh-huh.
A x yes, say that one.
Uh-huh.
Before that one, before it, there must be ax cube.
Oh, okay, that
Sir.
is yes.
Sir.
Yes.
Yeah, sir, he's right.
I think
Sir,
that's
he's
why
right.
that's where the error comes from when we're adding. Supposed to be a cube x. Sorry, as cube.
Yes, sir.
So that's why the as cube comes before the 3as cube.
I've already done the thing already.
You said?
Sir,
Yes.
sir, please, you are grouping items, so I think you don't need to worry much. We just need to correct it. That is all.
Yeah, that's what I'm saying. That is where when I was placing that one there, where we misplaced where we lost the as cube. Wait, so one is a cube x and one supposed to be as cube. So I don't think this one. No, that is not a mistake. It's correct. In the exception of what
Sir,
you've
it is
added first.
Yeah.
In the section of what you added first, it is not a mistake. Who asked the question?
Sir, it's me,
Your name?
Richard.
Richard.
Yes, sir.
Don't get confused.
Okay.
Can you see the cursor?
Yes, sir.
Okay. Have you seen the X here? The X here.
Yes.
When it multiply the A cube, what are we going to get? X times A cube will give us A cube X.
Yes, sir.
Are you okay now?
Yes, sir.
So it is not a mistake.
Sir, but before that,
Before,
before that,
Sir.
the
yeah.
A must multiply the last X cube. So that
that is, we've corrected that already.
Sir.
Yes.
Sir.
Yes.
See, you don't need to do much. You see, he is solving from A to Z. So if there's any
Richard,
yes, sir.
Justin talk.
As you said,
Yes.
we are solving from the beginning to the end. If there's any grouping you didn't do, and he got it, there is no need for him to say it's a mistake. If he got it already and the
But
final
I'm
answer
trying
is
to
the
tell
same.
him that what he says a mistake is not a mistake. Probably he is a bit confused over there.
Okay.
Richard, are you okay?
Yes, sir.
What you're talking about, the omission, the A times S cube, we've corrected that you should add it. Are you okay?
Yes, sir.
So can we
Yes, sir.
continue?
Yes, sir.
Any question again? Okay. So let's continue. Observations. Whilst the power of A is decreasing in magnitude, that of X is increasing in magnitude. Let's go back to the previous slide. You could see that whilst A is decreasing, the power of the first term of A is exponent 2. For the second term is exponent 1. The third term is exponent 0. You know 0 is 1. That is why it is lost over there. Then the power of the second term, x, in the binomial will also start increasing. So it will start increasing from 0. So it is going to give us x exponent 0. This will give us x exponent 1. This will give us x exponent 2. So you see that when the power of the first term is decreasing in magnitude, the power of the second term is increasing in magnitude. Always bear in mind, the first term and the last term will have the power of the exponent in the binomial. So when you check for exponent 5, the first term, the highest power there is exponent 5. The last term, the highest power is also exponent 5. When you check the fifth example, you could see that's for the exponent 4. The first term also have its highest power to be exponent 4, and the last term also has its highest exponent to be exponent 4. Our second observation, the sum of the powers of A and X is equal to the power of the binomial in each term. The sum of the powers of A and X is equal to the power of the binomial in each term. Now let's go back to the previous slide and check that. You could see that, let's take the last example here. The second term, when I add the power of a to the power of x, that's 4 plus 1. I will get 5. And we have 5 as our exponent in the binomial. That's a plus s into bracket exponent 5. Let's consider the third term. You could see that a cubed s squared. When we add the exponent, that is 3 plus 2, we are going to get 5. The same applies to the fourth term and the fifth term here. Third observation, the coefficients of the expansion a plus x exponent n being a positive integer, follows a particular pattern. We'll be looking at the pattern in the Pascal's triangle. Let's go back to the previous slide and look at an observation there. You could see that whenever we have an expansion, the number of times when we expand will be one more than the exponent. Let's look at the first example there. A plus x exponent 0. The number of times we have there is 1. So we have one more than the exponent. The exponent is 0. When we have a plus x exponent 1, the number of times we have is 2. And the exponent is 1. So in that case, we have the number of terms in the expansion to be 1 more than the exponent. The third example, we have exponent 2, but the number of terms we have here are 3. So when you are given an expansion to expand, always take note that when you expand, the number of terms should be 1 more than the exponent. What I mean is, if I have exponent 6, you must have 7 terms when you expand. When you have the exponent to be 7, you must have 8 terms when you expand. So when you check the last example, we have the exponent to be 5. That means we must have our number of terms to be 6. So when we count, we have 1, 2, 3, 4, 5, and 6. That is another observation we can realize. So when you have an expansion to do, consider the exponent that your number of terms in the expansion should be 1 more than the exponent. Please, if you have any question, raise up your hand, you unmute yourself, ask. Yes, Seraph.
Say.
Seraph, I can hear you.
So please, can you go over the
Go over what?
Can you go over the observations again?
Okay.
It's
Let's look at
a
the
little bit
first.
confusing for me.
Okay, I'll take the first observation.
The observations.
Yes. The first observation I'm talking about is they're saying, whilst the power of A is decreasing in magnitude, that of X is increasing in magnitude. And you know that A is the first term, X is the second term, right? So the increasing will start from the first term. Sorry, the decreasing will start from the first term. That's the first term will take the highest exponent. And then the increasing will go to the second term. Let's look at this. Okay, when you look at this example, you see how the expansion is done. We multiply the 2 terms, then the first term will start decreasing from the highest exponent to 0, and the last term, that's the second term, will start increasing from 0 to the highest power. So the first term 2, we take the first exponent. Don't copy this yet. I'm using it to explain. We will get to this point. The first term, we take the highest exponent. So when we are expanding, actually, we multiply the 3 terms together. That's one technique of how to expand a binomial. We take the term, we multiply throughout to the number of terms we have to get. So when you have to get, let's say exponent 4, you must get 5 terms. So we multiply the 2 terms, that's 2 and 3x. They are the 2 terms in the expansion. We multiply it, multiply and add 5 times. So when we are multiplying and adding, you are going to get 4 being the exponent of the first term, 2, and 0 being the exponent of the second term in our first term. So that's going to give us 2 exponent 4 times 3x exponent 0. Now when you move on to the second term in the expansion, you see that the first term in the binomial will decrease, while the second term will increase. So in that case, you have 2 exponent 3 times 3x exponent 1. Then we are going to get the third term to be 2 exponent 2. The first term in the binomial has decreased again by 1. So that's 3 minus 1 is equal to 2. Times 3x exponent 2. The 3x here also has increased from exponent 1 to exponent 2. Then the next term, our 2 is going to decrease again by 1, whilst the 3x will increase again by 1. Then in the next step, we are going to get 2 decreasing again to 0 and 3x increasing again to 4. So whilst the 3x increased to 4, that is your last term in the expansion. Now let's go back. So that is what we are saying, that whilst the power of A is decreasing in magnitude, that of X is increasing in magnitude. If you're still not okay, you can unmute yourself and ask the question. All right, let's continue. Then the second observation, we say the sum of the powers of A and X is equal to the power of the binomial in each term. Let's go back to the example we used. When we come back to this example, you see that when we add the exponents of the 2 terms, we are going to get 4. The second term, the exponents are 3 and 1. So 3 plus 1 is 4. The third term, we have 2 plus 2. That is giving us 4. This one, we have 1 plus 3, giving us 4, and 0 plus 4, also giving us 4. So that is one observation we can make. So we are saying that when you add the exponent of the 2 terms in the expansion, you must get the same result as the exponent in the binomial to expand. Our third observation is the coefficient of the expansion for n being a positive integer follows a particular pattern. We'll be looking at that pattern over here. But before we get here, let's look at the final observation I gave, that when you have an exponent in binomial, the number of terms when you expand is going to give you a term more than the exponent. So when you have exponent 5, you are going to get 6 terms. When you have exponent 4, in your expansion, you must get 5 terms. Exponent 3, when you expand, you must get 4 terms. Exponent 2, when you expand, you must get 3 terms. Exponent 1, when we expand, we get 2 terms. Exponent 0, when we expand, we get 1 term. Let's go to the pattern now. Okay. Over here, we are still concentrating on the coefficients. So the first example that we have coefficient of 1. The second one, we have 2 coefficients, that's 1, 1. The third one, 1, 2, 1. The fourth one, 1, 3, 3, 1. Then we have 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. The observation here, when we look at this, the coefficient here, you could see that they are forming a triangle. They are forming a triangle here. The coefficients. So when you are listing the coefficient, when the next one can exponent 6 and release the coefficient, you could see that they form a triangle. Now, over here, I just space them. I just space them. When we take the first and the second one, the previous one is in the middle of the next coefficients. That is the first exponent 0. Each coefficient 1 is in middle of 1, 1 for the exponent 1. Then the next one, we have exponent 2 having 3 terms. That is 1, 2, 1. Now, the observation we can make, or the pattern that can follow, is after the first and second term. When we come to the third example, the third binomial, you see that after the first coefficient, when we go to the next coefficient, that is the 2. When I add the top coefficients that the 2 here is in between, I'll get the result here to be 2. Don't be confused. Let me go to the next one and explain. When I take this 1 and 1, over here, after this first coefficient 1, the next coefficient is 3. And the 3 is in between the previous coefficient 1 and 2. So you could see that when I add the 1 and 2, it will give me the next coefficient that is in between them. So always, when you take the previous coefficients, the number that is in between them at the down, the sum of the top ones will give you that coefficient at the down. When I come here, 2 and 1 for exponent 2. Next to it down, we have 3 in between them. So when I add 2 to 1, I'll get 3. Now let's take the G and the E and see. When I come to the E, the coefficient, and this is always done right after the first coefficient. So our first coefficient here is 1. The next one, you can see that the 4 is in between 1 and 3 at the top. So when I add 1 and 3, I'll get 4. The next one, I have 3 and 3 at the top for 6 as the coefficient at the down. So when you add the 3 and 3 here, you are going to get 6 at the down here. When we take the next coefficient 4 of the expansion, is in between the top coefficient 3 and 1. So when you add 3 and 1, you get 4. Let's look at the final binomial. After the first coefficient 1, I have 5. And you can see that 5 is in between the top coefficient 1 and 4. So when I add 1 and 4, you get 5. The next coefficient is 10. It's in between the top coefficient 4 and 6. So when I add the previous top two coefficients, it will give me the 10 as the down coefficient in between them. The next step here, we have 6 and 4 again, and the coefficient in between them at the down is 10. So when I add 6 and 10, 6 and 4, sorry, I'll get a 10. And finally, I have 5 in between 4 and 1. So when you add the 4 to 1, you get 5. So always, when we add the previous two coefficients at the top, we'll get the down coefficient that is in between them. So you could say it is something doing like V, like this. When you consider this, it's like this. Sorry. This and this is making V. So the V at the down, the V corner is giving us the result when we add the top two coefficients like this. This also form V like this. In that order. Any question about the pattern? Okay, if there's no question, and this is what we call the Pascal's triangle. Pascal's triangle and it was named after a French mathematician and philosopher called Blaise Pascal. Blaise Pascal, he came out with this approach of expanding a binomial expansion. So Blaise Pascal, the French mathematician, is the reason behind the Pascal's triangle used in binomial expansion. So when you see Blaise Pascal anywhere, you thank him for his good work.
Is he dead or he's alive?
I think by now he should be dead.
And then he said where we will find him.
Don't worry.
Why he is ghosting?
You dare say Jimmy.
It's okay.
If you
let's
go to
continue.
heaven, you find him.
Yes.
I want to see him face to face.
That you can see him face to face.
Try. You want to see him face to
Then
face?
repent and go to heaven.
Go
That's
to the
all.
mortuary.
Die. Just die.
Mortuary.
Hey, our children. Oh, they are cursing me already.
That is there.
Okay, it's okay. Let's continue. It's okay. Let's continue. Using the Pascal's triangle, write down the expansion of the following. So we look at the first expansion. Now this is how we use the Pascal's triangle to expand a binomial expansion. Please listen. First of all, we need to write down the coefficients of that particular exponent. So when we go back to the previous slides, exponent 0, we have coefficient of 1. Exponent 1, we have 1, 1. Exponent 2, we have 1, 2, 1. Exponent 3, we have 1, 3, 3, 1. Exponent 4, we have 1, 4, 6, 4, 1. Exponent 5, we have 1, 5, 10, 10, 5, 1. So always we write down the coefficient of that exponent first. So in exponent 4, we have 1, 4, 6, 4, 1. That is the coefficient in exponent 4. 1, 4, 6, 4, 1. The next thing we need to do is to multiply. Sorry, the next thing we need to do is first we have to expand. And this is how we expand using the Pascal's triangle. First of all, you multiply the two terms. So the terms here are 2 and 3x. They're the two terms in the binomial. We first multiply them. We multiply and add the number of times you have to get in the expansion. How many times are we getting in this expansion? Answer. Answer, how many times are we getting in this expansion?
Say 5.
Okay. So first of all, what you need to do is we multiply 2 into bracket times 3x into bracket. You multiply and add 5 times. That is the first step. I hope you are all okay. The next step is,
Sir, please, I don't understand. Can you come over?
okay. What I'm saying is that to use the Pascal's triangle, you need to multiply the two terms. This is exponent 4, so you are getting 5 terms when we expand. So you multiply the two terms in the binomial. The two terms are 2 and 3x. As you can see on your screen. So we have 2 times 3x, 2 times 3x, 5 times. That is the first step. Are you okay now?
Yes, sir.
Okay. So after that, the next thing you need to do is we start decreasing and increasing the powers. So when you are multiplying after multiplication and adding, the next thing you need to do, you take the first term in the multiplication, that is 2. When we consider the first term in expansion, we are going to get 2 exponent 4 times 3x exponent 0. So you start applying the powers. So the 2 will take the highest exponent, that is 4. So it will start decreasing down to 0, whilst the 3x will start increasing from 0 to 4. Then when you go to the next multiplication, you decrease the exponent of 2 by 1 and increase the exponent of 3x by 1. So that will give us 2 exponent 3 into bracket, another bracket, 3x exponent 1. The third term, you see that the power of 2 has decreased again by 1. So we get 2 exponent 2. And the power of 3x has increased. That is 3x exponent 2.
Sir, please repeat yourself.
What?
I said for the third term, you see that the power of 2 has increased again. Sorry, it has decreased again. So previously it was exponent 3. And now it's exponent 2 in the third term. And the exponent of 3x has increased by 1. Previously it was exponent 1, and now it's exponent 2 in our third term of the expansion. When we go to the fourth term of the expansion, you see that the 2 has decreased again by 1. Previously in the third term, it was 2 exponent 2. But now it's 2 exponent 1. So you decrease its power again. Then the power of 3x has increased again by 1, giving us 3x exponent 3 now, previously 3x exponent 2. Our fifth term giving us 2 exponent 0. The 2 has decreased again by 1 in power. And the 3x now increased again to exponent 4. And that will give us our last expansion. So when you simplify that, 2 exponent 4 will give us 16. 3x exponent 0 will give us 1. So 16 times 1 is 16.
Yeah.
Okay, let's continue. 2 exponent 3 will give us 8 times 3x. Then 2 exponent 4, 2 exponent 2 will give us 4, then times 9x squared. Please be mindful in the bracket, the exponent is affecting both the x and the 3. So here we're going to get 9x squared. Then 2 exponent 1 will give us 2. 3x all cubed will give us 27x cubed. Then the next time we have 2 exponent 0 being 1, and 3x all exponent 4 giving us 81 exponent 4.
Sir,
Yes.
sir,
Yes.
please can you explain the second step? Please can you explain the second term, second step again?
The second step. 2
Yes, please.
exponent
I
4
didn't
is
get it all.
16. 2 exponent 4 is
Yeah.
16, right? And
Yeah.
it's multiplying 3x exponent 0. So the 3x exponent 0 is 1. So that gives us 16 times 1, giving us 16.
Mm.
Then the next one, I have 2 exponent 3 being 8. Are you okay, Justin? Times 3x
I
exponent
get it, sir.
1. So that will be x times 3x. The next one, I have 2 exponent 2 giving me 4. And 3x squared is 9x squared. Plus 2 exponent 1 is 2 times 3x all cube. And 3x all cube is 27x cube. Plus 2 exponent 0, that is 1, times 3x exponent 4. 3x all exponent 4 will give us 81 exponent 4. Any question? Okay, let's move on to the next step. Now the next step, we just simplify that. That will give us 16 plus 24x. 8 times 3x will give us 24x. Then plus 36x squared. That's 4 times 9x squared. Plus 54x cubed. That is 2 times 27x cubed plus 81x exponent 4. That is not the end of the expansion. We are now left with the coefficients. We are now left with the coefficients. Now, we take each coefficient and multiply by their respective terms. The first coefficient, we know that is for the first term. Second coefficient is for the second term. Third coefficient is for the third term. Fourth coefficient is for the fourth term. And fifth coefficient is also multiplying the fifth term. So we are now going to multiply each coefficient with their respective terms in the expansion. So we multiply 1 by 16, 4 by 24x, 6 by 36x squared, 4 by 54x cubed, and multiply 1 by 81x exponent 4. Any question? Any question? Okay, fine. When we simplify that,
Sir,
yes, this one.
sir, I have a question.
Ask.
Is it compulsory to multiply each term of the expansion by their respective coefficients?
Yes, please.
Okay, thank you.
That is when you are using the Pascal's triangle. In using the Pascal's triangle, over here, the expansion we did over here, how we did it, we did it without the coefficients. We did the expansion without the coefficient. That is why we listed the coefficient down first. So after expanding using this method, now we have to finally multiply each term by their respective coefficients listed above. So when we simplify, that will give us 16 plus 96x plus 216x squared plus 216x cubed plus 81x exponent 4. Any question?
When you're about to close.
You're not serious. That's why you can't wait my time.
Any question?
Yes, sir.
Ask.
Sir, please, if they give you question and did not ask you to find the Pascal, and they just ask you to stop, can you use the binomial expansion or the Pascal?
Okay, you can use that if they don't ask you per se to use the Pascal, but then it has a limitation. Is that okay? The Pascal's triangle has a limitation in such a way that when you have
Okay.
a larger exponent, it becomes tedious. That is maybe when you're given binomial to exponent 20. That means you have to follow this pattern. You have to follow this pattern and create up to exponent 20. You know, even if you buy foolscap, it can contain on one page. Are you getting it? Now, when we have negative exponent, the Pascal's triangle is also limited here. We can't use it to expand when you have a negative exponent. Maybe a plus x exponent -2, -3, or a fraction. We can use the Pascal's triangle for exponent half, exponent 1/2, exponent 3/2, because we can't get the coefficient for them using the Pascal's triangle. So the Pascal's triangle has a limitation. We can't use it for larger positive integers, and we can't use it for fractions and negative numbers.
Okay, sir, thank you.
Welcome. You have the second example, that is 3 minus x exponent 5. When you go home, you're already home, sorry. After the class, what you're going to do is you try your hands on them. When we meet in our next class, you see, we will look at your expansions and compare with what I have to see if you've really understood what we did. Then if there's any problem, then we go over it, solve it, then we continue. Okay. Have a nice day, everyone.
Say, what's the question again?
Okay, ask.
Yeah.
Yes.
If you are given a question and you don't specify whether you should use the expansion method or the Pascal triangle, which one do you prefer to use?
We are not there yet. We have the main binomial theorem, a theorem that we use for the expansion. When we have even negative numbers, fraction, or higher exponents. We have a theorem to use to do all this expansion. A theory can do all. That one, it has no limitations.
Okay. Thank you.
Welcome. Is there any further question before I end the class? So I would like everybody to solve self-party exercise A and B. Then we continue with more complex example and linear equations. Amujinu,
Sir,
yes, ask.
please, I'm done.
With the first one,
All of them.
all of them.
Yes.
Okay, the first one, how did you get?
4 whole number, 3/52.
3/52.
Yes.
And the second one?
2.
2.
Yes.
Okay, let's wait and verify.
Okay.
Yeah, let's wait for
Okay.
your friends to finish.
Okay.
Sir,
Yes,
sir,
yes.
sir, please, the second one I had two. I had two for the second one.
And have you finished the first one?
I'm not doing it, so.
Okay, so you finish. Please let's be fast a bit with it.
So the first one I got 20.
The first one you got 20.
Yes.
Is that Eric?
Yes, sir. Says it's me.
Sir, please, the first one I had 4.
The first one you had 4.
Yes, please.
Please don't see this on the screen and compare it. There are 2 different equations, I guess. All right. So don't say that this is different thing and compare with it. Please let's be fast a bit. In the next 5 minutes, we should finish. Please, those who have unmuted themselves, please mute yourself. If you have a question to ask, you raise up your hand, you unmute, then ask. Please, everybody should mute. This or herself. Gloria, mute yourself. Gloria, mute your audio.
Sir,
Yes.
the first one I had 4.
The first one you had 4.
Yeah. Sir, it was decimals 4.0 by 4. So like
4.0. Okay. Please, let's hurry up. We have about 3 minutes to finish that.
Sir,
Sarah,
sir,
I'm listening.
the first one I had 4 whole number 3 over 52.
You had 4 number 3 over 52. And the second one?
Yes, I got 2.
So please, let's be taking note of our friends' answers. Once you note your own down, so that we will see where the mistakes are. Those who have already finished. Please, let's hurry. It's almost time. Has everyone finished?
Sir,
Yes.
I have the first one, 4.1.
Okay. Note your answer down. Eric,
Sir,
you say you had a 4.1, right?
yes.
Sir, please, I can't see anything.
You can't see anything on the screen. You can't see anything on the screen. Who's having the problem? Who's having the problem? Are you okay now? Okay. It's okay. Everybody, let's stop work and let's discuss the solutions. The first one, some people say they had 4. Those who had the 4, did you approximate?
No, sir.
Done.
Yes,
Say
sir.
no, say no. I didn't approximate. So
You had
like,
a whole number.
Like it's in that it was in decimals. It was 4.01.
say yes, it was in decimals.
So
That's
only
I'm
the
asking.
first one.
That's what I'm asking you. Did you approximate your answer to 4?
Yeah.
Sir, yes.
That's what I was asking.
If you
Okay.
use your hand, you want me to give you 4.0.
I think you should get something 4.05 something.
Sir,
That's
yes.
converted into decimals.
4.057.
But in
Yes,
fraction,
that's
is that
Then said the approximation should be 4.1.
okay? That's also correct. That's to 1 decimal
sir.
point. Yes,
What if you get 4/3/52?
it's also correct. Very correct. That's a fraction form. I think you are going to get 112/52. Sorry, 211/52, right? That will give us the 4 whole number 3/52. And I hope the second everybody had the 2.
Yes, sir.
Yeah.
Sir, yes.
Okay, good. Any question pertaining to the first and second, the linear equations, before we take the complex examples? Okay, if there's no question, then we continue with our complex examples. I think this is where we were last week and we couldn't finish it. So we are going to continue with the example 1. We couldn't finish even example 1 last week before we had the interruption. So we're going to take that again. For the practice exercise 1, we have 6x plus 1 over 4x minus 1 is equal to 3x plus 2 over 2x minus 1. Let's look at how we go about this. For this particular example, we could see that the terms at both sides of the equation are just binomial. Are we okay with that? If anyone is having problem why the terms are monomial, it's not binomial. The terms at the left hand side and right hand side, they are all monomial. The 6x plus 1 over 4x minus 1 is monomial. And then on the other side too, it's a fraction. It's also a monomial, one term. If anyone is having problem why we have monomial at both sides of the equation, the person can ask, so that I'll clarify that. Okay, I assume everybody's okay with that. That we have monomial. Yes, L. Ackley, Sayram. L, please ask your question. Unmute yourself and ask.
Sir,
Yes.
please, I'm asking why we have the two terms as monomials.
Please, do you know what a monomial is?
Uh-huh.
You don't know a monomial. Okay.
Uh,
I think in our previous discussion, we look at what a binomial is and what a monomial is. Let me quickly refer you to that. Have you seen this example and the linear equations? And the linear equation where we have the x plus 2 equals 5. L, are you okay? L. X plus 2 is binomial. 2 terms joined with plus or minus sign is a binomial. And we did that in algebraic expressions. You see the 5 here is alone. That is what we call monomial, one term. One term is a monomial. If I have x plus 1 is binomial, 2 terms. Whenever 2 things are joined with plus or minus sign, then we have what we call binomial over there. But if it is just a term, then that term alone becomes a monomial. 2x is monomial, 3x is monomial, x divided by 2 is monomial. It's one term because it is not joined by plus or minus sign. So in that case, it becomes one term. If you look at these solutions, the 3x over 3 is one term. It's just one term. When I come to the solution C, 4x is just a term, but not 2 terms. But where we have the 4x minus 5 is binomial. Below it, we have 4x minus 9x. It's also binomial because here 2 terms, they are joined with plus or minus sign. However, plus or minus is in between 2 things, then we have what we call binomial. But if the terms are multiplying, for instance, 4x or 4x over 2, still we have a monomial, one term. Al, please, are you okay? Al, I want to hear you out. You say
Yes,
you
I'm
are okay.
working.
Okay,
Yes, I'm working.
okay. All right. So we have monomial at both sides of the equation. Whenever we have an equation that has fractions at both sides, then what we need to do is, first of all, we have to cross multiply by the means of taking the numerator of the fraction at the left hand side, multiplying it by the denominator of the fraction at the right hand side. So the numerator of the fraction at the left hand side is 6x plus 1, and the denominator of the fraction at the right hand side is 2x minus 1. So I'll multiply the numerator of the left hand side by the denominator of the right hand side fractions. By way of doing that, we say we cross multiply. Then we equate it to, then I'll take the denominator of the left hand side and multiply by the numerator of the right hand side. And please, I said anytime you are multiplying, famous, who is that, Phantom 6 or whatever, please mute yourself. L, L, speak. L, speak. Actually, L, speak. Yes, perpetual.
Sir, please, what if you move all the characters to one side and equate it to 0. Then afterwards, you get your 9x minus 1 and you equate it to 0. Then you move the 1 back to the other side of the equation. You still get the same answer, but is that method approachable?
Yeah.
So it's allowed.
Yes, it's allowed. But when you want to use that approach, be careful that first of all, you need to find LCM and multiply through. In that case, it will become a fraction subtracting a fraction.
Okay.
Addition or subtraction of fractions. Is that okay?
Yes, sir.
So when you are finding the LCM to multiply through, instantly you don't eliminate the denominator. Do you get me?
Yes.
Okay. So let's continue. So when we cross multiply, and please be mindful, anytime a binomial is multiplying binomial, we put them into brackets. Anytime a binomial is multiplying binomial, you put them into brackets. That is 6x plus 1 is a binomial, 2 times. Multiplying 2x minus 1, also binomial. So you put both into brackets. If you don't put them into brackets, then you are going to have your equation to be wrong. Mathematically, it is wrong. L, ask your question. L, since you have network problem at your end, I can't hear you at all. But you kept on raising up your hand. So please quickly correct that.
Help.
Say, leave him so that you can continue.
So let's continue. So I was saying, if you not put a binomial into bracket before multiplying, you are going to have your equation to be wrong. And mathematically, it is wrong. Because it is a bracket multiplying 2 times multiplying 2 times. So they must be in brackets for you to expand. Then we equate it to, we multiply the denominator of the left-hand side by the numerator of the right-hand side. That is going to give us 3x plus 2, which is the numerator of the right-hand side, times 4x minus 1, which is the denominator of the left-hand side equation. Then we put both also into brackets. The next thing we need to do is to expand the brackets. In expanding the brackets, first term here, we'll take it and multiply through with all the terms in the second bracket. So that is 6x times 2x will give us 12x squared. 6x times minus 1 will give us minus 6x. Then 1 times 2x will give us plus 2x. 1 times negative 1 will give us minus 1. That is for the left-hand side of the equation. Then we move on to the right-hand side. That is 3x. We take the first term of the first bracket to multiply through the terms of the second bracket. So we're going to have 3x times 4x will give us 12x squared. Then 3x minus 1 will give us minus 3x. Then we use the second term also to multiply through the terms in the second bracket. So that will give us 2 times 4x, we're going to have 8x. So that will give us plus because it's positive. Then we have 2 times minus 1 will give us minus 2. The next thing we need to do we have to simplify first. Simplifying the terms that are alike and they are adding or subtracting, we add and subtract the like terms. So when we simplify the left hand side, 12x squared is not having any like term at the left hand side of the equation. Minus 6x and 2x are like terms. They have the same characters, xx. So we need to simplify that. So minus 6x plus 2x will give us minus 4x. Then minus 1 is not having any like term at the left hand side here as well. Let's move on to the right hand side of the equation. 12x squared at the right hand side is not having any like term at that side of the equation. So it remains 12x squared. Minus 3x plus 8x are like terms. So we add them at this side of the equation. So minus 3x plus 8x will give us 5x. So we have 5x here. Then minus 2 at the right hand side of the equation is not having any like term here. It also remains minus 2. So in all, we're going to have 12x squared minus 4x minus 1 is equal to 12x squared plus 5x minus 2. Then from here, we group like terms. Grouping like terms, you group all the x's to one side. The terms that contain the x's, I have 12x squared minus 12x squared, because over here 12x squared here must cross the equal sign and come and join it like terms 12x squared, because they are alike terms which has x squared in each. Then 4 minus 4x is having a like term with 5x. So we group them together, minus 4x minus 5x. Because the 5x is positive at the right hand side, when it joins the minus 4x at the left hand side, it becomes minus 4. We have minus 2 at the right hand side here and minus 1 at the left hand side. And I want to group the minus 1 and minus 2 together. So when the minus 1 crosses the equal sign, it becomes positive. So I'm going to get minus 2 plus 1 at the right hand side. From here, we need to simplify. In simplifying, we add terms that are like, as usual. 12x squared minus 12x squared. It becomes 0. They are terms that are alike. Then minus 4x minus 5x will give me minus 9x. Then we move on to the right hand side. Minus 2 plus 1 will give us minus 1. Again, there's a need to group like terms. There's a need to group like terms here because minus 9x and minus 1, then 9 is not belonging to the formula of x. We want to solve for x in this case. So there's a need to group the 9 and the 1 together. But anytime we are solving equation like this, we want to make the variable the subject. So the coefficient of the variable here must be positive 1. Sorry. The coefficient of the variable here must be positive 1, please. So the x here must have positive coefficient of 1. So we need to divide both sides by -9. When we are grouping like terms and they are multiplying, we divide. So we need to divide both sides by -9, sorry. Let me finish and get back to you, please. So dividing both sides by -9, I have -9x divided by -9 is equal to -1 divided by -9. Then when -9 divide -9, it will become +1 times x will give us x. -1 divided by -9 will give us -1/9. It's no problem if you leave your answer in this form. And it's no problem if you convert this into decimal as well. But if you convert this into decimal, I think you're going to get 0.11111 recurring. Is there any question?
No question.
Okay, please, if anyone is having any question to ask, raise your hand, unmute yourself and ask. I'm giving you a minute to decide whether you have a question or not. Then we can continue. Sorry, about 10 seconds to decide. A minute is too much. Give me 10 seconds. If no question on board, then we can continue.
Sir,
It's Justin.
sir, please, I think we should move on.
Okay. In the absence of any question, we continue. I'm happy you've all understood these parts. Example B. This is another complex. For this example, what we need to do is, first of all, before you cross multiply, you could see that the left hand side of the equation is binomial. That is 2x minus 1 over 3x minus 2 minus 4x minus 3 over 6x minus 2. So this is giving us binomial because there are two things and they are joining together with minus sign. But the right hand side is monomial. So first of all, we need to simplify the left hand side of the equation to a monomial before we cross multiply. So first of all, we have to simplify the binomial aspect. So anytime you are solving a mathematics question or problem, please make sure that you simplify all complex expressions first. That's the first step you have to look at. We need to simplify all complex expressions in our mathematical problems. That's the only way you can easily find the best solution or the best solution path to your problem. L, ask your question. L. I can hear L. Elsie Aloka, ask.
Sir.
Answer, hold on. Elsie Aloka. Elsie Aloka, I can't hear you good. It seems you have a network problem. Rectify that. Yes. Yes, I can hear you now. Elsie, ask your question. I can hear you.
You can hear that talk.
Just ask that, sir, please. I can't see anything on my screen. Not. No, can I
Elsie,
hear
I can't
anything?
hear you. Answer, ask your question. Elsie, correct your network problem.
Sir, my own, it wasn't a question. I was just coming to tell you that L said I should tell you he can't hear anything.
I can't hear her either. He says she's having a network problem at her end.
Sir, no, my
Continue
question.
our lesson now. Sir, they are sending us back. Let's continue.
I think.
Loka, I will give you the last chance. If your network is not good again, then we continue.
Sir.
Yes, ask your question.
Sir.
Talk loud.
So I want to ask that, does it?
Chai, your network is not good there.
Keep quiet,
Walk around.
Eric, keep quiet. Let's continue. Elsie, rectify your network and get back to us. I will address your problem. Okay. So there's a need for us to simplify the left-hand side, which is the binomial. And that is the complex aspect of the equation. So we use the LCM of the two fractions. We need to find the LCM as we did in algebraic expressions, addition and subtraction of fractions. So we need to find the LCM first, like how we'll be adding and subtracting fractions. So the LCM here is the same as multiplying the two denominators. That is 3x minus 2 times 6x minus 2. It will also give us the LCM of the two fractions at the left-hand side. Then we take the first fraction, we use its denominator to divide the LCM. That is 3x minus 2 into bracket 6x minus 2 divided by 3x minus 2. So when we divide 3x minus 2 by the LCM, you could see that the 3x minus 2 will divide or cancel the 3x minus 2, leaving 6x minus 2. Then we multiply the 6x minus 2 by the numerator of the first fraction. So that will give us 2x minus 1 into another bracket 6x minus 2.
Question solution.
Please, if you have a question, you raise your hand I will allow you to unmute yourself. Then we consider the second fraction. We use its denominator. So after the first multiplication, we have the minus sign here. So it will be minus. Assuming it is plus, then we bring plus here. But since it is minus, then we subtract the numerator of the simplification. So we use the second fraction, its denominator, to divide the LCM again. That is 6x minus 2 divided by the LCM. When this cancels this, we are going to get 3x minus 2 as our result. Then we multiply the result by the numerator of the second fraction. So in that case, we are going to get 4x minus 3 into bracket times another bracket 3x minus 2. Please, if you have any confusion or problem with the first step, raise up your hand. Let's clarify that before we continue. Eric. Unmute yourself. Yes, Eric. Ask your question. Eric, I can't hear anything.
Sir, please go over the first one again.
Okay. I am saying that if you want to simplify this binomial, there are fractions, okay? Like how we'll be doing it in algebraic expressions, addition and subtraction of fractions. We take the LCM first. That is the first thing we need to do. So the LCM here is by multiplying the two denominators. So the denominators are 3x minus 2 and 6x minus 2. These are the denominators. So multiplying the denominators, we have 3x minus 2 into bracket, another bracket 6x minus 2. This becomes our LCM, least common multiple of the two fractions. Now, to simplify, we need to take the denominator of the first fraction and divide by the LCM that we have found. Then we use the result after dividing to multiply the numerator of that fraction. So when I divide the LCM by the denominator of the first fraction, that will give me 3x minus 2, another bracket 6x minus 2 divided by 3x minus 2. Then the result is going to give me 6x minus 2 because 3x minus 2 will cancel the 3x minus 2. Then I will multiply the result to 4. Please let me land. I'll get back to you. I'll multiply the result 6x minus 2 by the numerator. That is 2x minus 1. So I will get 2x minus 1 into bracket, another bracket, 6x minus 2. Yes, to for Savannah. Unmute yourself and ask your question, please.
I said, what you just explained, I didn't understand it.
What I just explained, you understand. Okay. Let me give you this illustration. Do this rough work somewhere. Let's add 3 over 4. 3 over 4 plus 7 over 5. I said we are adding 3 over 4 plus 7 over 5. So we learned how to add fractions. We did this in real number system and similar thing in algebraic expressions. So when I want to add these two fractions, I'm going to first of all find the LCM. And the LCM of these two fractions is what? 2 for Savannah. Please, what is the LCM?
20.
Good, 20. And you know, finding the LCM sometimes is the same as multiplying the two denominators. But it's not always the case in multiply. Though if you multiply, you get common multiple. But it's not all the cases that it will give you the list. But in this case, the LCM here was the same as when you multiply the denominators.
Yes.
Okay. So when I find the LCM, which is 20, what do we do next? 2 for Savannah.
Sir,
Yes.
you do it 4 into 20, how many times? Then you multiply it with the top one, that is 3.
So 4 divided by 20. We divide the 20 by
5.
4, right? That will give us 5, isn't it? That's 20 divided by 4 will
Yes.
give us 5. Times 3, the numerator. That will be 15, right?
Yes.
Okay. Hold on there. Let's get back here. The LCM here, you see this one, they are variables, isn't it? The denominators, they are variables. They contain variables. So the best way we can find the LCM is to multiply the two denominators. So when we multiply the two denominators, that will give us the LCM. That is 3x minus 2 and then 6x minus 2. So as we did using the 3 over 4 plus 7 over 5, we divide the denominator, we divide the LCM by the denominator of the first fraction. So for, are you okay with that? To 4, Savannah, are you okay with that?
Yes,
Yes,
sir.
sir.
Okay, then we use the results here. When we divide the LCM by the 3x minus 2, it will give us what? To 4, Savannah. To 4, can you please answer the question so that we quickly continue? Okay, let's continue. So when we divide the LCM by the denominator of the first fraction, I'll be left with 6x minus 2. Then we multiply the 6x minus 2 by the top expression of the first fraction. That is the numerator, 2x minus 1. Then I will get 2x minus 1 into bracket, another bracket, 6x minus 2 minus another bracket, 4x minus 3. That is the numerator of the second fraction, multiplying the result, which is 3x minus 2, when I divide the denominator 6x minus 2 by the LCM. So I'll get 4x minus 3 into bracket, another bracket, 3x minus 2. I hope you're all okay with this. Still, all over 3x minus 2 into bracket 6x minus 2. Please, in this case, you need not to eliminate the fraction because they are subtracting. When they are adding or subtracting, you need not to eliminate. Let me give you one simple way to do that so that you don't get confused. Let me give you one simple way. Another simple way to do is when you take the two fractions, then we can multiply as if we are crossing multiplying. I'll multiply the 2x minus 1, that's the numerator of the first fraction, by the denominator of the second fraction, 6x minus 2. Then I'll multiply again the 3x minus 2, denominator of the first fraction, by the numerator, as if we are crossing multiplying. So by the numerator of the second fraction, 4x minus 3. But when you cross multiply here, we don't eliminate the fractions because they are not equating. When they are equating, that is why we eliminate the fractions, the denominators, sorry. But in this case, we don't eliminate the denominators because they are not equating. When they are adding or subtracting and you cross multiply, then we need to multiply the denominators as well. We'll divide the whole thing. So when I cross multiply here, I have 2x minus 1 times 6x minus 2 minus 4x minus 3 times 3x minus 2. Then all over, I will multiply the denominators. That is 3x minus 2 minus 6x minus 2. Then equals the left-hand side, sorry, the right-hand side of the equation. The second step here, we need to simplify. In simplifying, we expand the brackets. 2x times the first bracket here, 2x times 6x will give me 12x squared. 2x times minus 2 is minus 4x. Then minus 1 times 6 is minus 6. Then minus 1 times minus 2 will give us plus 2. Then minus, here, let's put the whole thing into bracket because of the minus sign. So we are going to do the expansion in the bracket. So minus into bracket here, 4x times 3x will give us 12x squared. 4x times minus 2 will give us minus 8x. Minus 3 times 3x will give us minus 9x. Then minus 3 times minus 2 will give us positive 6. Bracket close, all over the denominator again equals the right hand side, the 1 over 3x minus 2. Then we simplify again. I'll have 12x squared minus 10x, that is minus 4x minus 6x, giving us minus 10x, plus 2x, minus, then we expand the bracket here, minus 12x squared. Over here, minus 8x minus 9x will give us minus 17x. But after the bracket here, I have minus sign here. So minus here will multiply the minus 17x, giving me positive 17x. Then minus here multiplying the positive 6 will give us minus 6. All over the denominator equals the right hand side. Please, okay, Alan, ask. Alan, Saka, ask your question.
Sir, please, I can't hear you clearly.
You can't hear what?
It's like your voice is breaking from my end.
Then I think it's the network. Everybody, unmute yourself, please.
Then
Sorry,
plus
everybody, mute yourself. Yes, who is asking? Sylvester. Père Agbonyo, ask your question.
Sir.
Père Agbonyo, ask your
Sir.
question. I can't hear you good. Please, if the network is not good at your end, you can't hear me good. So make sure you have a good network then.
Sir.
Yes.
Sir.
Yes.
Please, in the third part of the equation, why did you put them in brackets? Third part, the 12x
Yes, I
squared
put it
minus
into
8x
bracket because
minus.
if you are not careful and you are expanding, okay, and you not expand with the minus sign, then you know the minus sign is affecting the whole bracket. And you know, expand with the minus sign is going to make your equation very wrong. That is the reason why leaving the minus sign outside the bracket, I have to put it into bracket before I expand because of the minus sign here. Please, I hope you are
Yes, sir.
okay.
Yes.
Who is that singing? Mute yourself and keep quiet. You're in class. So, Abdul, Wahid, Mohammed, ask your question. Abdul Wahid, ask your question.
What's going on?
I can't hear you, Wahid, so we are continuing. So, when we simplify further, we get 12x squared minus 12x squared is 0. That is adding like terms and subtracting like terms. Minus 10x plus 17x will give us 7x. Then 2x minus 6, 2 minus 6 will give us minus 4. So when we simplify the denominator, when we simplify the numerator of this part of the equation at the left hand side, we'll get 7x minus 4 over the denominator, which is 3x minus 2 into bracket 6x minus 2, equal to 1 over 3x minus 2. Please, is there any question or confusion so far? Please, any question? Okay, let's continue. Now, yes, answer. Answer, please. Unmute yourself and ask your question. Answer, I can't hear you.
Okay, so please the answer 7x minus 4 over the 3x minus 2 times 6x minus 2. So why won't you multiply the 3x minus 2 and the 6x minus 2?
You see, anytime you are solving this kind of equations, where it is necessary for you to expand, you expand. But if it is not necessary, don't expand for your equation to be simple. Is that okay? So it's the same thing when we leave it like that, but we just need the equation to be simple. So I think at this point, the denominator is not necessary yet for us to expand, so that we can work with simple expressions. So you have to look out where it is necessary for you to expand, you expand when you have brackets. But when it is not necessary, leave the brackets like that so that you can have simple expressions. Are you getting me? Though if you expand, it's the same thing, but you might get confused alongside. If you're not extra careful, you will get confused and you make a mistake. Answer, I hope you're okay.
Yes, I'm okay.
Okay, to first Savannah, you raised up your hand. Ask your question.
Fair.
Yes.
How will you know it's necessary for you to expand your brackets?
Okay. Have you seen before the last step here? The numerator. Okay, the second step. Let's take the second step. You see, we need to group like terms. We need to group like terms here. So grouping like terms here, there's a need for us to expand the bracket. Even the first step, when you look at the first step, you could see that we are working with both sides of the equation. And before we can proceed with simplifying the equation, there's a need for us to, first of all, expand the bracket at the numerator. We need to simplify the numerator first. That is the most necessary thing. So you have to look out, where do I need to expand the bracket? Over here, there's no need yet to expand the bracket at the denominator. We can't cross multiply straight from here. Even if you cross multiply straight from here, still there's a need for you to what? Expand. But looking at the numerator here, you see it is too complex when you cross multiply, because when I take the denominator at the right hand side to multiply the numerator at the left hand side, when I cross multiply, this bracket is going to multiply this whole expression, and the whole expression is complex. That means this denominator at the right hand side in one bracket multiplying the whole of this, and the whole of this seems to be a binomial. because this bracket and this bracket becomes one term, and minus 4x minus 3 into brackets 3x minus 2 also becomes one term. So in this case, the numerator here is complex when we cross multiply. So look at first, there's a need here. We need to simplify the numerator. Tufa, please, are you okay with the explanation? And is everyone
Yes, sir.
okay? All right.
Yeah, so we are fine.
Okay, let's proceed. Now, I have my equation in a simplified form. 7x minus 4 over 3x minus 2, one bracket, another bracket, 6x minus 2 is equal to 1 over 3x minus 2. Can someone tell me what we need to do over here? Eric, please help us with this.
This is where people confuse more. How? That whole time, do you
Tell me.
understand now? This.
So you cross multiply.
Donne, you answer when I called you. So
Sir, please, I heard my name. Sir, you called me.
Has been answered already.
Okay, sorry.
After Desmond, you raise your hand. Please ask your question.
Yeah, I had wanted to answer, but since Donnie answered, it's all right.
Okay, let's proceed. So when we cross multiply, that will give us 7x minus 4 into brackets times 3x minus 2, another bracket, is equal to is equal to 1 times 3x minus 2, bracket open and close, another open bracket, 6x minus 2, bracket closed. Then from here, we need to expand the brackets at both sides of the equation. So expanding the brackets, I have here 7x, first the left hand side, 7x times 3x is equal to 21x squared. Then 7x times minus 2 is equal to minus 14x. Then minus 4 times 3x is equal to minus 12x. Then minus 4 times minus 2 will give us plus 8. Equal to, then we expand the right hand side also. You know, 1 times the whole thing is the same thing. So there's the need to just expand the two brackets containing the 3x minus 2 and 6x minus 2. So 3x times 6x will give us 18x squared. Rosman, please let me finish with this, then ask your question. 3x minus 2 is equal to minus 6x. Then 2 minus 2 minus 6x is equal to minus 12x. Minus 2 times minus 2 is equal to plus 4. Yes, Mama Rosemont, please, you can ask your question now.
Sir.
Yes.
Sir.
Yes, I can hear you. Ask your question.
Sir, I can't hear anything. No.
I think it's your network. I'm ever rejoice. Ask your question.
I can't hear anything.
I think it should be your network. I'm ever rejoice. You raised up your hand. Okay, let's continue. Now, when we expand or the bracket, now we need to simplify. Yes, I'm ever rejoice. Unmute yourself and talk. You did not unmute, so I can't hear you. I'm ever rejoice. Please unmute yourself and ask your question. Agbenyopo, ask. Agbenyopo, unmute yourself and ask your question. Okay, let's continue. Yes, Pearl. But your network is bad. So rectify that and get back to us, please.
Sir, please, it's like I can't hear you. I can't hear anything.
Is the network at your end? Because I can also find it difficult to hear you. So let's simplify now. That is 21x squared is not having any like term at the left hand side here. So we leave it like that. Minus 14x minus 12x will result in minus 26x. Then plus 8 here is not having any like term at the left hand side. It also remains like that at that side of the equation. Now let's move on to the right hand side of the equation. 18x squared is not having any like term at this side, so it remains 18x squared. Minus 6x minus 12x will give us minus 18x. Plus 4 is not having any like term here at this side of the equation, so it remains the plus 4. Then we group like terms. When we group like terms, I have 21x squared minus 18x squared, giving us 3x squared, then minus 26x plus 18x, giving us minus 8x. Then plus 8 minus 4 will give us plus 4. Is equal to 0. So we have 3x squared minus 8x plus 4 is equal to 0. Eric, please, can you tell us what kind of equation is this? 3x squared minus 8x plus 4 equals 0. Eric, from 1 at 3. Edu, Eric, what form of equation is this? Eric, said what kind of equation is this? 3x squared minus 8x plus 4 is equal to 0. Yes, Amu Junu.
Sir,
Yes.
it's a quadratic equation.
Thank you. It's a quadratic equation. That's very good. We did this in algebraic expression and how to factorize quadratic equation or how to solve it. So we need to solve this quadratic equation as we did in algebraic expressions. So when we solve 3x squared minus 8x plus 4 is equal to 0, that is going to give us, first we need to factorize it. So when you go back to algebraic expressions, we learned how to factorize quadratic equations or expressions. Then we're going to have the factorization will give us x minus 2 into bracket, another bracket, 3x minus 2 is equal to 0. Then at this point, we need to equate each bracket to 0 and make x the subject. We need to equate each bracket to 0. So taking the first bracket, x minus 2, we equate that one to 0 and make x the subject. So x minus 2 is equal to 0 will give us x is equal to 2. That is our first value of x. Then 3x minus 2 is equal to 0. When we find the value of x here, it will give us x is equal to 2 over 3.
Please, I can hear you.
I think it's your network. So when we equate each of the brackets to 0, we're going to get x is equal to 2 and x is equal to 2 over 3. There's a need to verify, that is putting each value of x that we found back into the equation. The whole equation, to see if the two values satisfy the equation we have. So when we verify with 2, you can do that and check 2 satisfy the equation at both sides. When we substitute 2 into the left hand side of the equation, it will give us the same value when we substitute 2 for x into the right hand side of the equation here. But when we substitute 2 over 3 into the equations, we are going to get undefined expressions. So the undefined expressions does not satisfy the equations at both sides. We need not to get undefined expressions. That is why we said x is equal to 2. Since x equals 2 over 3 does not satisfy the equation this. Please, any question?
answer.
Yeah, baby girl.
So Rejoice, please. I think the problem is on your end. I think it's a network problem.
Oh, oh, who is that?
Who is that?
Please behave, everybody. So that is the solution for X. X will give us any question. If you have a question, you raise your hand and ask. If you have a question, raise your hand and ask. Okay. In the absence of any question, I will be uploading some questions on the Google class. You get there by evening 6 p.m. You get the questions and then do the assignments over there. I'll give every instruction over there. Thank you all for today. All the best. See you next time.